Alright, these are some test corrections for graphing quadratic functions. The test that we've just had, we had 5 sections. We're going to look at the first section first. We're looking at problem number 2. So this is an example of how to do this type of problem. This is the quadratic parent function section. So each of these numbers means something different to us. The 4 tells me that there is a stretch by 4, and it's also going to give me the general idea of my slope. The -1 right here is in x world, so it means anything in x world means we shift either right or left. Since this is -1, -1 means we're going to shift right 1 unit, and then at the end down here, -3, this is the area that tells me whether we shift up or down. So since it's negative, we're going to shift down 3 units. I can tell my vertex from looking at this to begin with because this -1 right here and the -3 that's right here, together they make my vertex of 1, -3. Remember, anything that's inside of x world is going to be opposite. So it says x -1, so we're going to have +1 here, and -3 gives me the -3. If you have trouble with that vertex, then you should go ahead and graph it first and then see where you are. So we've discovered stretch 4, right 1, down 3. So starting at the origin, I'm going to go right 1 and down 3. So right 1, down 1, 2, 3. That's going to be where my vertex is, right? Hopefully I can get the dot. There it is. Okay, so now if you look at this, I've moved right 1 and down 3. The coordinates of this point are 1, -3. So that's your vertex, 1, -3. The stretch is by 4, so we're going to do a slope as if it were 4. So I'm going to go up 1, 2, 3, 4, and right 1. And then I'm going to mirror that on the other side over here. And then when I connect these 3 dots, then I've got my quadratic equation, and it's been graphed. Okay, now for domain and range, remember that if it's a parabola, which all of these are, and we know it's a parabola because of the square up here, if it's a parabola, the domain is all real numbers, no matter what, every time, always, it's all real numbers. The range, however, is either going to go up, as in this one goes up, or it's going to go down. If it goes up, that's above, so greater than or equal to, and then all we have to do is check and see what is this lowest value right here, and that's a -3. So the domain is all real numbers, the range, y, is greater than or equal to -3. And that's an example of the quadratic parent function section from section 1. In section 2, we're looking at the standard form. So in standard form, we have ax squared plus bx plus c. So that means that my a is 4, my b is 8, my c is 1. I know that to find my vertex, I'm going to say x is -b divided by 2a. So for this problem right here, x is going to be -8 divided by 2 times 4. That's -8 divided by 8, which is -1. So the x value of my vertex is going to be -1. To find the y value, I'm going to plug back into my equation. 4 times -1 squared plus 8 times -1 plus 1. So that's 4 times 1 minus 8 plus 1. So 4 minus 8 plus 1 equals negative 3. So my vertex, when I put the 2 points together, my vertex is at negative 1, negative 3. So I'm going to go negative 1, 2, 3, and this is where my vertex dot's going to be. Now, one way I do this is to check and see where my y-intercept is. Remember, the y-intercept is always the c. Whatever the c is the y-intercept. My y-intercept here is 1, so I'm going to put a dot at 1. I hope, if it'll work. And then I have to mirror that, so I'm going to put the mirror point over here, and when I connect these 3 dots and then extend it through, there is my parabola. And that's all I have to do to graph it. Now, which way does this open? It opens up. What's my vertex? Negative 1, negative 3. So putting that together, I have negative 1, negative 3 for the vertex. The axis of symmetry. The axis of symmetry is an imaginary line that goes through here. Since the axis of symmetry is a line, it has to be an equation. So the axis of symmetry is x equals negative 1. That's my axis. X equals negative 1 because it is a vertical line. The last two things that we have to put down are whether or not this is a maximum or a minimum. It's the lowest point, so it is a min. And what is that minimum point? Well, it's my vertex. So the minimum point is negative 1, negative 3. To see section 3 and section 4, go to the next video.